Climate change is the mother of all externalities. It is larger, more complex, and more uncertain than any other environmental problem. Those are the written words of my guest today in 2009. And as an economist, the natural question is then to ask what the damages are of those externalities. What do those damages consist of? How large are they? And what are the uncertainties? And my guest today, Richard Tol, has been one of the leading scholars in trying to answer those questions, and in particular to the use of an integrated assessment model called the FUND model. And this acronym stands for the Climate Framework for Uncertainty, Negotiation, and Distribution. And this type of model takes estimates of climate change and economic outcomes to arrive at estimates of economic damages. And we'll talk a lot more about that later. But first, I want to provide some context on the importance of the FUND model, because when I was doing my PhD in economics from 2012 to 2018, there were kind of three leading integrated assessment models that I saw as I saw it. One was by Bill Nordhaus, who got his Nobel Prize in economics for that work. One was from researchers at the University of Cambridge, and one was the FUND model by Richard Tol. And these three models were used by the Obama administration to arrive at a number for the social cost of carbon, the guiding number for all cost-benefit calculations in the United States related to climate change. So these models have greatly shaped US environmental policy. Now, my conversation with Richard covers all of these topics, both the technical aspect, like what goes into one of these models, and what are the key choices economists have to make. On the other hand, we also discuss the use of these models in policy. Now, the full conversation is an hour and 10 minutes, and I thought that was just too long, so I split it up. And in this first part, we talk about what the integrated assessment models are actually trying to do, how Richard got into building the model, and why adaptation, development, and public goods and sectoral detail can substantially change the economics of climate change. And then next week in part two, we'll move from how the model works to how these models are used in real policy debates. So that was a long introduction. Now let me just give you the bio of Richard and then we'll get started. Also, let me give you some of his bio, which is very impressive. So Richard is a professor at the Department of Economics at the University of Sussex and a professor of the economics of climate change at the Institute for Environmental Studies and Department of Spatial Economics at the Vrije Universiteit Amsterdam. He is a member of the Academia Europaea and a fellow of the Royal Economic Society. Richard received a Master in Science in Econometrics in 1992 and a PhD in Economics in 1997 from the Vrije Universiteit Amsterdam. And just to give you an idea of his incredible impact, he has over 300 publications in journals with 100 plus co-authors. And he's ranked among the top 100 cited economists in the world, as well as the top 100 most cited climate scientists. He has published 2 books, 3 edited volumes, and many minor publications. He specializes in the economics of energy, environment, and climate, and is interested in tourism and scientometrics. So Richard, welcome to the podcast.
Thanks for having me.
When I started this podcast, a conversation with you about FUND was actually on my wish list, so I'm very excited to have you on. But not all of my listeners might not be aware of what integrated assessment models are. So could you just give us a sense of what they are and what they are used for to start us off?
Integrated assessment model consists of 3 words, right? And the last one is model, which is essentially a mathematical or computational representation of how we think the world works. The word assessment in integrated assessment model refers to the fact that these models are meant to advise policy. They're not designed to further our understanding of reality, but they're designed to improve policy. And the word integrated, the first word in integrated assessment model, means that the model is constructed to respect the boundaries of the problem rather than the boundaries of academic disciplines. So in the case of climate change, you would have components that are demographic, you have components that are economic, you have engineering components, you have a carbon cycle, that is how CO2 moves in the atmosphere, and the other carbon sinks the ocean and the terrestrial biosphere. You would have a climate model, would have impact models that are partly economic, but also partly have to do with human health. So you span all the disciplines that are necessary to understand the climate problem.
So thank you for that explanation. And then I'm wondering what got you started on these types of models, or what made you decide to pursue them?
I don't think it was my decision at all. Just after I graduated, I was looking for things to do, and I found this job at the Institute for Environmental Study. I'm still affiliated with them. And even though my original training was in econometrics and statistics analysis, they put me on this project, which was much more cost-benefit analysis and a lot of game theory, how to set up, or essentially how to do international negotiations around climate change. And yeah, this was not my first choice, and in the beginning I did not really like it. But I mean, after a while, you sort of like get used to what you're doing, and you're getting better at it, and it becomes more interesting as you understand more of it. So it was basically not by design, but was an accident, right? As John Lennon says, life is what happens to you while you're busy making other plans.
Yeah. And was it then a part of your PhD that they put you on this project?
This eventually turned out to be my PhD as well, right? I started way before in 1992, actually, on this project, constructing this integrated assessment model. And that was then a major part of my PhD.
Because at the time, I think Bill Nordhaus published his first paper in 1992, or maybe earlier, on the DICE model. Did you
actually?
Yeah. Did you go about it? How did you then go about constructing the fund model? Like, because it's just, to me, it's like such a big exercise, and you have so many components that just starting it just seems.
It's been a long time, right? I mean, Nordhaus's work was known at that time, right? And essentially, what we planned to do was, because at the time we did not know about Zili Yang and the rice model. That was actually fairly advanced at that stage, but we were not aware of that. We were aware of the works of Carlo Carraro and Scott Barrett, right? They were known as working papers at the time. So essentially the plan was to build a multi-regional version of DICE, and deviate from Barrett and Carraro by having heterogeneity in the regions. They, at that time, assumed that every country is the same, which is a peculiar assumption that I still don't understand how game theorists work with that. So that was the starting point, and that was the aim. How do you start building a model? Well, you start by understanding what needs to go into the model. Unfortunately, we had at that time a good bit of guidance from Nordhaus, right? What are the components and how would that look like? Not just Nordhaus. The CETA model of Peck and Theisberg was actually slightly earlier than Nordhaus. We had access to those things as well. And yeah, you just start building. The main challenge was in regionalizing the model and regionalizing the impacts of climate change. Where actually Sam Venkhouser's work, also only available in draft at that stage, was a big help.
I think that's one of the big differences at the time versus the DICE model, is that you exactly started, I think, creating these 16 regions. Versus the DICE model of
16 came later, yeah.
Okay, versus the DICE model exactly was like just one model for the world.
Yes.
So then, once you got into that, are there other parts of fund at the time that started differentiating from the other models?
Well, one thing fund has always done differently than all other integrated assessment models that are used for cost-benefit analysis, apart from now the GIVE model, right, by RFF, is that we make, and in that sense we are similar to GIVE, is that we have separate impacts for different sectors. Because I never quite understood why all these sectors should move in tandem, not as assumed, why they should all have a quadratic functional form and those sort of things. But conceptually, more importantly, because different sectors develop differently depending on how the economy grows. You would also naturally create dynamics in your impacts. And that is something that a structure like the Page model or the DICE model completely lacks. If you look at the equations in the DICE model, then the impacts of climate change are a function of climate, actually a function of temperature. And then they're just scaled up and down with the size of the economy, but such things as the provision of public goods or the structure of the population was simply not in there, right? And we know that those things are important because adaptation is terribly important for the impacts of climate change. And a good part of adaptation has to do with the provision of public goods. And Nordhaus essentially assumes that the provision of public goods is constant over space and over time, which is a very peculiar assumption. And similarly, if you look at health impacts, such things as malaria particularly fall on children between 0 and 6 months old. Things such as heat stress fall particularly on the elderly, and assuming that the structure of the population doesn't change over time is also a very peculiar assumption to make, right? So by allowing different sectors, you could put in more of that richness of how impacts of climate change evolve over time. But it would also allow you to follow Tom Schelling's advice. Now Schelling is, of course, a very prominent economist, and he won the Nobel Prize for his work on game theory. But his contributions to the economics of climate change are a little bit overlooked. But he was actually, Nordhaus was the first one to talk about climate change, the first economist to talk about climate change in 1977, 75 even. But Schelling was not long after, published his first piece in the public literature in 1984 already. And from the very early start onwards, Schelling has always said that developing countries are much more vulnerable to climate change than our developed countries, for the reasons I just sketched, but also with the structure of the economy and so on and so forth, access to technology, provision of public goods. But that immediately implies that there's two ways of going about reducing the impacts of climate change. One is reducing greenhouse gas emissions, and that is the only tool that Nordhaus allows. But you could also either stimulate economic growth in general, or you could target particularly vulnerable sectors through targeted development aid or targeted technological change, that would also reduce the impacts of climate change without actually affecting climate change directly. And that is one thing where the fund model deviates and differs from all other integrated assessment models, that we actually have those policy options in the model too. And almost all integrated assessment models. Because, these things keep popping up left, right, and center, right?
Yeah.
Since we started, way back when. So that is one of the main differences in the structure of the fund model compared to many, if not most, if not all integrated assessment models, that we allow an investigation, of those sort of things as well. And that actually has turned out to be important, as well as it also has borne out in reality, right? If I think back to the 1990s, one of the things that people were terribly worried about at that time was what climate change would do to the spread of tropical diseases like malaria. And people were talking about millions premature deaths per year because of the spread of malaria. And that concern has now basically, gone away because first Bush the Younger came with his bed nets, right? And then we reversed the ban on
Yeah.
DDT. And then Bill Gates funded the development of a malaria vaccine. And malaria is now technically under control at the moment. Um, the problem is the Trump administration and its attack on foreign aids that is sort of like reversing the progress that was made under the previous Republican president. Um, um, but that is probably temporary, and that big concern, malaria, has essentially been taken away by a better provision of public health and by technological progress in the medical sector. And that is something that a model like DICE simply can't do. It's simply not designed to ask that question, whereas FONT is designed to ask that question.
It was also a big point of my advisor, Michael Greenstone, that, like you said, the impacts of extreme heat on mortality are mostly skewed towards the elderly. But then, especially in countries where there's less adaptation, like there's no air conditioning, there's no heating. So it's like, I don't know if, it's like as income progresses, people are also have an easier time to adapt.
Mm-hmm.
So it sounds, for example, that the dice wouldn't. So would that then not, would that be easier to capture in the fund model or?
Yes, absolutely. And I mean, Michael Greenstone, I think, was a co-author on the Deschênes paper, Olivier Deschênes,
Yeah.
where they looked at the sensitivity of mortality to heat over a century in the United States and found indeed a secular decline in how vulnerable populations are, particularly because of air conditioning, but also improvements in medical care, right? In healthcare. No, absolutely. And Fund is designed to look at those things. And that is, I think, its main selling point.
Then, because on the flip side, it sounds very hard what you did, because then you've got these multiple sectors, and now you've got to also find the, I don't know what the right word is at this point, like parameterize or find some impacts from the literature, because you've got these different regions, you've got these potential sectors. This is just a much harder, problem, because you're, breaking it down. How did you go about then just trying to get the estimates for the model?
Essentially, what I now realize from does, but I wish I had realized earlier, is essentially it's a meta-analysis, right? So you have all these different impacts. And essentially what I did was I read the literature, which was still at that time pretty thin,
Yeah.
and essentially synthesized from that literature. So for the impacts of climate change on agriculture, there were 4 or 5 published studies. And essentially what we did to fund was the average of those 5.
Yeah.
Similarly for health, there were a handful of studies. In some cases, there was only 1 study, right? And that is essentially what I use. Over time, of course, the literature has thickened, not by as much as people think, but definitely there's not more literature on the impacts of climate change nowadays than there was in the mid-1990s. And the recalibration of the model still follows the same principles, namely that what goes into fund is typically the average and the standard deviation of what you would find in the literature on a particular impact. And the same is true for the costs of greenhouse gas emission reduction. Essentially, what goes in there is not a calibrated model or calibrated parameters, but essentially parameters that are the average of what you would find in the literature about the cost of reducing methane emissions or the cost of reducing CO2 emissions or nitrous oxide or what have you.
I maybe misunderstood it, but I think you said maybe you should have realized this earlier. Would have that like shaped it in a different way? That it's like a kind of a meta-analysis.
Well, when I first did this, I did not even
Yeah.
know of the existence of meta-analysis.
Yeah.
Just what I did.
Okay.
Um, and also the literature was so small that there was no real need to formalize how to do this. But as the literature grows, there's of course more and more studies, and it's becoming harder and harder to explain what all the choices that you make in summarizing the literature.
Yeah.
So one of the things that I'm currently working on is indeed formalizing this whole process of the data that you would find in academic papers to the parameters that you would find in the integrated assessment model.
Yeah.
Uh,
And yeah.
it's
Sorry. Go ahead.
a statistical problem.
Yeah. Yeah. This because there's the exactly which parameters you use to inform a model, and then you also have a database for the meta-analysis of the social cost of carbon. Sorry, these were my own words, but I don't know if that was correct. But you have a database including 528 papers on integrated assessment models. So
Mm-hmm.
not that many, and then a lot of them were published recently. I think almost like 10% of them were published in the last year. Is this because it has become easier? Because like you said, there weren't that many studies to pull from, there were not that many models. Like, how have you seen the evolution?
The literature on the social cost of carbon is by now very big
Yeah.
and growing very, very rapidly. um, and one of the things that I think is wrong in policy advice is to rely on a single estimate. Because there's so many degrees of freedom, there's so many things that reasonable people can reasonably disagree on, that I think it's much better to have a panel of experts, right? But lacking that, what you can also do is just summarize what is in the literature. And that is interesting in all sorts of ways. You can detect trends, you can detect blind spots, you can sort of detect people parroting each other, and all those things are going on in this particular literature. When I did my first meta-analysis of the social cost of carbon, it was a relatively thin literature. And at that point, I made the decision to include all published estimates, or all estimates that seem to have some influence on policy. And the reason for that is to just increase the sample size so that you can do more interesting statistical analysis. But second, I mean, meta-analysis is a well-established statistical procedure. But in this case, a meta-analysis on the results of models is actually something very, very different, right? Because this is not a sample.
Yeah.
Population, and these are not observations, but these are model outcomes, right? So actually doing a statistical analysis on this requires some different approaches, and of course the main purpose of publishing an estimate of the social cost of carbon is to say this is what the tax on greenhouse gas emissions should be, right? That is the purpose of the social cost of carbon. So at that stage, to increase the sample size, but also reflecting the purpose, I decided to also include sort of republished estimates, that in order to sort of like figure out what people are saying in this literature, if people were publishing a slight variant of the DICE model with a slightly different number, then I would use this to say, well, this is the most prominent model, this is the most prominent advice. It's not just Nordhaus who's saying this, but it's actually Nordhaus saying the same thing over and over and over again. And then other people picked up his model, made a few tweaks to the model, and published essentially the same result. That actually increases the weight of the policy advice because this is a way of measuring pedigree, essentially. So I made that decision way back when. And that is now coming to bite me because there are now many such publications where people essentially pick up typically work by the US EPA, work by RFF, work by Nordhaus, and say, I'm going to use this because this is the best estimate of the social cost of carbon. And that is actually where most of the growth of the literature is coming from. Not necessarily original estimates or independent estimates, but people essentially endorsing previous estimates, including a lot of miscite previous studies, which is quite intriguing. How they say, I'm going to use Reynolds number and then not use Reynolds number, but something different.
So that was part one of my conversation with Richard Tol. Next week in part two, we move from the structure of fund to its role in policy, including the social cost of carbon, the Obama-era EPA, and why misunderstood models can be dangerous. And if you've listened all the way to the end, thanks so much for sticking with me, and I can't wait to share part two. See you in the next one.